All right, so this is 3A, solving quadratics by factoring. To do this, what we need to do is we need to make sure we know what standard form of a quadratic is. The standard form is ax squared plus bx plus c, and that's going to equal 0. So really we need to get all of our like terms together, get our a, b, and c terms on one side, and make the equation equal 0. Now the a, tried your best, or not try your best, but sorry. The a, try making it, make sure it's positive. So we want a positive a. That is our goal here. So okay, we're gonna move through the steps. I'll talk about it as I'm working through. So number one, we have moved terms to one side of the equation, of the equal sign, to get the equation in standard form. A should be positive. So right now I'm looking at my a term, that's the x squared. There's no other x squareds in the problem. My a is positive 2. So I'm going to move all the terms to that side. So I'm going to subtract 84 and subtract 84. There are no like terms with the constant 84. So it's going to be 2x squared minus 2x minus 84. Okay, so that's in standard form. Now, this is kind of Mr. Johnson's made up word, but we're going to undistribute the GCF, the greatest common factor, if there is one. So between looking at all the individual terms, 2x squared, 2x, and 84, is there a number that I can divide out all of them? Can also be a variable, but right now we're just looking at numbers. They're all divisible by 2. You can divide them all by 2. That is the biggest number. That's my GCF. So I'm going to undistribute, so I'm going to divide it and put it out front, the 2, leaving me with a 1x squared, which is x squared, minus 1x minus 42. Now, one thing that I failed to mention at the very beginning here is the biggest exponent will always tell us how many solutions we have. So we have 2 solutions. Our solutions are always with the biggest exponent. That's how many are in the problem. The 2, the GCF, does not have an x on it, so there will be no solutions with the 2. My solutions still all are within the parentheses here, this quadratic. So we need to now break this down. We're going to factor it. So to factor it, we are going to factor the remaining quadratic. We're going to do a times c. So we have our a is 1. So a times c, and it's negative 42. So it's, I make the x. So 1 times negative 42 is negative 42. And that's a times c, and then what adds to b. So the b is negative 1. So I gotta think, what 2 numbers multiply to negative 42 that add up to negative 1? So if you can't think of it off the top of your head, you just do numbers that multiply to 42, and that doesn't add up to negative 1. That doesn't add up to negative 1, but if I put a negative on the 7, negative 7 times 6 is negative 42, and that adds up to negative 1. So negative 7 and 6, those are my 2 numbers that multiply to the top that add to the bottom. So negative 42 multiply and adds to negative 1. We are going to now use the Punnett square. In the Punnett square, I'm going to do this, write it, and then I'm going to erase it. In the top left is my a term always. So this will be x squared. Then in my bottom right is the c term, negative 42. The other 2 are going to be my b terms split. So we're going to split them up. We're going to split them up with the 2 numbers that we just came up with, negative 7 and 6. So let's do this. So we have the Punnett square. Top left is my a term, which is x squared. My b term is the negative 7 and the negative 6 and the positive 6. They have to add up to the middle term though. So we have to have x's on them. So negative 7x plus 6x is a negative 1x. And then the bottom right is the c term, negative 42. Now, take out your greatest common factors of each row. So the bottom row is 7. My top row is x. When it comes to variables, it's always the smaller of the variables. So this is squared, and this is technically x to the first. So it'll just be x, or x to the first, that comes out. Greatest common factor of each column. So last column will be 6, and the first column will be, again, x. Now the signs always come from whatever sign is next to. So the bottom left, if it's negative, it'll be a negative. Top right, if it's positive, then it'll be a positive that'll come out. So my two factors are x plus 6 and x minus 7. And then you set each one equal to 0, each factor, and solve. So subtract 6, you get negative 6. Add 7, you get 7. Those are my two solutions to this problem. All right, let's take a look at number 5. So again, we move all the terms to one side. We already did that. It's already done. Is there a greatest common factor between 4x squared and 25? No. There's not a greatest common factor. So we move on. We got A, B, and C. Well, my A is 4. My C is negative 25. Well, what happened to B? B is always a number. B is going to be 0. You could rewrite it as this if you wanted to see the 0. So we have our A is 4, our B is 0, and our C is negative 25. Okay, make sure that subtraction comes as a negative. So we do our component square. So it's A times C, which is 4 times negative 25, and that's negative 100. What multiplies to negative 100? That'll add up to B, the 0. So this is always your B down here. And that'll be 10 and negative 10. Those multiply to negative 100, they add to 0. Now let's break this down. Punnett square. Top left is your A term, so our A term is 4x squared. My next two blanks on the top right and bottom left are going to be my B terms split up. So it's going to be 10x and negative 10x. It does not matter the order you write those in. And then the C term is the bottom right. Take out your greatest common factor of each row. The bottom row is 5. And since it's a negative 10, it'll be a negative 5. The negative, it'll be negative. That always dictates the sign. Top row is 2 and x. First column is 2 and x. And last column is just a 5. Since this top right is positive, it'll dictate the sign of the greatest common factor that came out. So it'll be plus. Set both factors equal to 0 and solve. So I gotta subtract 5, divide by 2, and x equals negative 5 halves. And then I add 5, divide by 2, and I'll get 5 halves. So I can rewrite them separately, but typically you'll see it written this way. Since it's a positive 5 halves and a negative 5 halves, you can write it as one simple equation. You have a positive 5 halves and a negative 5 halves there as two solutions. All right, number 6. So as we're working through, we have it in standard form already. Is there a greatest common factor? And there happens to be a greatest common factor of 8x. Well, in this case, this is the first time we've had it where a greatest common factor has a variable with it. So when you divide by 8x, your first term will be x, and then 64x divided by 8x is 8. Well, now one of our solutions is with the greatest common factor. Our other solution is inside with the x minus 8. So we're going to set both of these, and you notice we don't have a quadratic anymore. We have 8x to the first. That means one of the solutions there because it's x to the first. Another solution is with the x minus 8 because that's to the first also. Set both factors equal to 0 and solve them. Now the first one you just divide by 8. You get x equals 0. Next one you add 8 and you get x equals 8. There are two solutions. All right, let's take a look at number 8. So here it's already in standard form. And is there a greatest common factor? Yes. You can divide by 9. Take a 9 and undistribute. 9 does not have an x on it, so there is no solution that's going to be found with the greatest common factor. Inside, we have x squared minus 1 equals 0. Well, what's my a, b, and c here? My a is 1. My b is, there's no b, so that's going to be 0. And my c is negative 1. So sometimes we get this a little confused. We're doing a times c, so what two numbers multiply to a and c? So that's 1 times negative 1 is negative 1. That adds up to 0. So what two numbers multiply to negative 1 that add up to 0? Well, that also is negative 1 and 1. Those multiply to negative 1, and they add up to 0. So now work this out with your Punnett square. Top left is your a term, so x squared. The next two come with your b term, so negative 1 and 1, but they have to have x on them. So they're going to be as the x term, and c is your bottom left. Take out your greatest common factor of each row, so the bottom row is 1. And because it's positive 1 in the bottom left, it'll be a positive 1. Top row is x. First column is x. And last column is 1, and because it's a negative, it's negative. So one of my solutions is x minus 1 equals 0. My other solution is x plus 1 equals 0. Solve them both. So add 1, subtract 1, and we have the positive and negative the same, so we're just going to write it together. So x equals a positive 1, and x equals a negative 1. That's what this means.